before evaluating the limits at infinity of polynomial functions, there is a need to understand the following. Number 1, the limit of c as x approaches infinity is equal to c, where c is a constant. Example letter A, the limit of 6 as x approaches infinity is equal to 6. The answer is 6 even if x is approaching positive infinity or negative infinity. Letter B example, the limit of negative 9 as x approaches infinity is equal to negative 9. The answer is still negative 9 even if x is approaching positive infinity or negative infinity. Number 2, the limit of x raised to the exponent r as x approaches positive infinity is equal to positive infinity for all r greater than 0. Example letter A, the limit of x as x approaches positive infinity is positive infinity. In this example, the exponent of x is understood to be 1. Example letter B, the limit of x squared as x approaches positive infinity is equal to open parenthesis positive infinity close parenthesis squared is equal to positive infinity. In this example, the exponent of x is 2. Number 3, the limit of x raised to r as x approaches negative infinity is equal to positive infinity if r is even and r is greater than 0. And it is equal to negative infinity if r is odd and r is greater than 0. Example letter A, the limit of x squared as x approaches negative infinity is equal to open parenthesis negative infinity close parenthesis squared. When you square negative infinity, the answer is positive infinity. And the exponent here is 2, which is an even number. So the answer is positive infinity. Letter B, the limit of x cubed as x approaches negative infinity is equal to open parenthesis negative infinity close parenthesis cube is equal to negative infinity. The exponent is 3, which is an odd number, and this is greater than 0. So the answer is negative infinity. Number 4, the limit of c over x raised to the exponent of r as x approaches positive infinity is equal to 0, where c is a constant and r is greater than 0. Example letter A, the limit of 1 over x as x approaches positive infinity is equal to 0. In this example, the value of c is 1 and the exponent is understood to be 1. Example letter B, the limit of 2 over x cubed as x approaches positive infinity is equal to 0. The value of c in this example is 2 and the exponent is 3. Number 5, the limit of c over x raised to the exponent of r as x approaches negative infinity is equal to 0, where c is a constant, r is greater than 0, and x raised to r is defined for negative values of x. Example letter A, the limit of 1 over x as x approaches negative infinity is equal to 0. Example letter B, the limit of 5 over x squared as x approaches negative infinity is equal to 0. Number 1 example. The limit of 5x raised to the exponent of 4 minus 3x squared plus 4 as x approaches positive infinity. Let us evaluate the limit of this polynomial function using the first method. The first thing to do is to factor out the variable with the highest exponent, in this case, x raised to the exponent of 4. Divide the first term, 5x raised to the exponent of 4, by x raised to the exponent of 4. This is equal to 5, right? 5 here. Next, divide the second term, negative 3x squared, by x raised to the exponent of 4. This is equal to negative 3 over x squared. We subtract the exponents in division. So 4 minus 2 is 2. So we have minus 3 over x squared. Next, divide positive 4 by x raised to the exponent of 4. So plus 4 over x raised to the exponent of 4. Next, find the limit of x raised to the exponent of 4 as x approaches positive infinity. And then find the limit of each of the terms inside the parentheses as x approaches positive infinity. So we have now the limit of the quantity 5 minus 3 over x squared plus 4 over x raised to the exponent of 4 as x approaches positive infinity. The limit of x raised to the exponent of 4 as x approaches positive infinity is positive infinity. And the limit of 5 as x approaches positive infinity is 5 because 5 is constant. And the limit of 3 over x squared as x approaches positive infinity is 0, so minus 0. The limit of 4 over x raised to the exponent of 4 as x approaches positive infinity is 0, so plus 0. 5 minus 0 plus 0 is equal to 5. So we have now positive infinity times 5, and positive infinity times 5 is positive infinity. So the final answer is positive infinity. Example number 2. The limit of negative 7x raised to the exponent of 5 plus 6x squared minus 9 as x approaches negative infinity. The first thing to do is to factor out the variable with the highest exponent, in this case, x raised to the exponent of 5. So divide the first term, negative 7x raised to the exponent of 5, by x raised to the exponent of 5. This is equal to negative 7. Write negative 7 here. Then divide the second term, 6x squared, by x raised to the exponent of 5. This is equal to positive 6 over x cubed. We subtract the exponents in division. 5 minus 2 is 3. So write plus 6 over x cubed. Then divide negative 9 by x raised to the exponent of 5. So we subtract 9 over x raised to the exponent of 5. Next, find the limit of x raised to the exponent of 5 as x approaches negative infinity, and then find the limit of each of the terms inside the parentheses as x approaches negative infinity. So we have now the limit of the quantity negative 7 plus 6 over x cubed minus 9 over x raised to the exponent of 5 as x approaches negative infinity. The limit of x raised to the exponent of 5 as x approaches negative infinity is negative infinity because the exponent 5 is an odd number. The limit of negative 7 as x approaches negative infinity is negative 7 because negative 7 is constant. The limit of 6 over x cubed as x approaches negative infinity is equal to 0. So plus 0. Then minus the limit of 9 over x raised to the exponent of 5 as x approaches negative infinity is equal to 0. Negative 7 plus 0 minus 0 is equal to negative 7. So this is now equal to negative infinity times negative 7. Negative negative is positive, so the final answer is positive infinity. Let us go to the second method. You can use this method if the test is multiple choice. However, if your teacher wants you to show the solution, use the first method. In this method, cancel all the terms in the polynomial except the leading term. So cancel negative 3x squared, cancel positive 4. What remains is only 5x raised to the exponent of 4. Find the limit of 5x raised to the exponent of 4 as x approaches positive infinity. So this is equal to the limit of 5 as x approaches positive infinity is 5. And the limit of x raised to the exponent of 4 as x approaches positive infinity is equal to positive infinity. 5 times positive infinity is equal to positive infinity. So this can be done mentally. The second one, the limit of negative 7x raised to the exponent of 5 plus 6x squared minus 9 as x approaches negative infinity. Cancel positive 6x squared, cancel negative 9. What remains is only negative 7x raised to the exponent of 5 as x approaches negative infinity. The limit of negative 7 as x approaches negative infinity is negative 7. And the limit of x raised to the exponent of 5 as x approaches negative infinity is negative infinity because 5 is an odd number. Negative times negative is positive. So the answer is positive infinity.